How are you doing today?
Good, how are you?
I'm good, thank you. Good afternoon, David. Hey, really quickly before we start, you guys, if you'll look at your grades really fast, I just updated them and see if you're missing anything. I want to make sure that you guys get everything turned in that you need to get turned in. Sarah, you ready? Zoom? Huh? Oh, okay. All right. Isaac, sorry about your computer. Yeah, typing in chat is totally fine. We'll wait just a couple more minutes. No, not minutes. We'll start now. It's 12:27, isn't it? Okay, so today we're going to just take notes together over rectangles. So if you don't have your Canvas course up, go ahead and pull your Canvas course up and go to 7.4 notes for rectangles, and we're going to look at a couple of activities in here. Give you a second to pull that up. Good afternoon, Carly. We're on the Canvas course looking at 7.4 notes rectangles. So we don't have an assignment today. Your assignment for today is a post in the discussion, okay? So make sure that you're posting here in the discussion. That's your grade for today. And let's look at this activity really quickly. We're going to be talking about rectangles, and here's our little note really quickly. Let me make our screen bigger. So here's a rectangle right here. If you click on that, you can go ahead and mess with it a little bit. If you pull the pink bubble things, it makes it bigger and smaller. And when you slide, you can see what happens to the angles and the diagonals here. So looking here, just watching the diagonals, pulling all the way across before I pull the diagonals or the angles here. What do you notice about the angles of our rectangle? They're going to be all congruent. So notice that as I'm just going to take this little arch here and copy it, meaning that all of my angles are congruent. And then if you look, same length for the diagonals are also congruent. So those are the couple things that we're going to be adding to our notes from our parallelogram. So go back to your notes here, fill out that discussion post there. You can go to the activity yourself and look at those angles and diagonals there. All right, let's go ahead and take notes on rectangles really quickly. We'll have a fast class today. If you have your math journal out, go ahead and grab it out. If you have the blank notes out that look like this, you can use those too. So the last couple of times we've talked about quadrilaterals and parallelograms. We're just going to continue our talk here today. So quadrilateral, we talked about, has just a four-sided figure. And last time we talked about a parallelogram, which is a four-sided figure, right? It is a quadrilateral, but it has all these additional properties, right? It has 5 additional properties. That's what we talked about last time. Today, and I'm going to show you all of this all together, we're going to be talking about rectangles. So I'm putting this in a row like this because it's kind of like a family tree. And we'll continue to look at the family tree together. So think about like the quadrilateral as the grandfather. The parallelogram has everything the quadrilateral has, plus a couple of properties. And the rectangle has everything the parallelogram and quadrilateral have, plus a couple of properties. So we're going to look at the rectangle properties today. So in your journal, go ahead and write these properties down. Give you a second to write those down, or if you just want to take a screenshot of it so you can have it. Notice that opposite sides are congruent, opposite angles are congruent, opposite sides parallel, diagonals bisect each other, consecutive angles or supplementary. Those are the same properties as a parallelogram, right? They're the same ones that we wrote down last time. And then here's the two additional ones that we just looked at in the GeoGebra. All angles are right angles and diagonals are congruent. So diagonals are the same, all right? So I'm trying to keep my voice down because we have an English class in here too. So if you can't hear me, let me know, I'm sorry. All right, let's look at some of these examples. Write this down with me, okay? Here's our example number 1. We have quadrilateral MNOP, and it's a rectangle. So it follows all of our properties of this rectangle here. So I'm gonna turn this over and show you all of our properties, right? It says M to O is 2x minus 8, and N to P is 23. So I'm going to use my highlighter here to show you what those are. M to O is 2x minus 8, and N to P is 23. Can you tell me, I'm going to put numbers next to these, which property are we going to use to solve for x here? Put a number in the chat. Go ahead and tell me in the chat, Kimberly, Joel, Jayana, David, and Isaac, which property are we going to use that tells us how to solve for this? They're diagonals, right? So we want to look for one of the properties that deals with diagonals. Good job. Good job. You're almost there. You're on it. This one says diagonals bisect each other. And look at number 7, diagonals are congruent. That's the one we're going to use. So if I know diagonals are congruent, that means that these are equal in measure, right? So I'm going to solve this by setting them equal to each other. Awesome job. Thank you for participating. So let's go ahead and work on this. We're going to add 8 here. So we have 2x equals 31 and divide by 2, and x equals 15.5 or 15.5. Let's do another one just like this. Moving on to example 2. I'm going to leave that there so you can copy it down. Let's go to example 2. Go ahead and write with me, okay? Example 2 says quadrilateral JKLM is a rectangle. LP, these are our diagonals here. P is in the middle. LP is 3x plus 7, and MK is 26. So we're going to use our knowledge of diagonals. Oops, LP is 3x plus 7, and MK is 26. So here, let's label this. If LP is 3x plus 7, that's only half of the diagonal, okay? MK is 26, that's the whole thing. So we know 2 things. We know our diagonals are congruent, right? They're the same, they're equal in measure. And we also know that our diagonals bisect each other. So if LP is 3x plus 7, then the other side is also 3x plus 7 here, okay? So I know that 3x plus 7 plus 3x plus 7 equals 26, okay? So let's solve this. We're going to combine our like terms here. 6x plus 14 equals 26. Subtract 14, 6x equals 12. Divide by 6, and x equals 2. Now I know that was really fast, but here's what I want you to know about this. that not only does it bisect, it cuts it in half, 2 equal parts, right? That they're equal to each other. Okay, so JL equals MK right there. Let's try one more, last example. Example 3. This is the same as example 2, so it's like doing it over again. But now you're going to get to practice. So we have A, B, C, D. It's a rectangle. We have diagonals again. P is in the middle. AC is 4x minus 13. And DP is x plus 7. So let's look at this. It's the same, just like example 2. If AC is 4x minus 13, that's the whole thing. And DP is x plus 7. Go ahead, take 2 minutes and solve for x here. So take 2 minutes and solve for x here. I'm going to start setting it up just like I did on the last one. If this is x plus 7 here, this is x plus 7 here. When you're finished, put your answer in the chat so I know that you're done, okay? You good, Joel? Awesome. Check your chat. I sent you a question. Perfect. Yes. Yeah, once you get it, go ahead and tell me what you got. Awesome. Okay, time is up. If you look here, same exact as like the last one. Both parts are going to add to get our whole thing, and they're congruent, right? So if we put our x's together, put our numbers together, and then eventually divide, good. Then we should get 13.5. I saw a couple of you answer in the chat. You're awesome. If you got that right, give yourself a pat on the back. Great job. So biggest thing that I want you to know here today is that we talked about parallelograms and rectangles. They're related to each other in that a rectangle has everything a parallelogram has, but 2 more qualities, right? All the angles are 90 degrees and the diagonals are congruent, okay? So that is the end of our notes today. I will see you guys on Friday. We'll have